All right, so I would like you to try to attempt these two problems on your own. Once you've done them, well, obviously I'd like you to pause this video. When you're done with them, unpause and check your work. For the developing Pick's theorem for the area of a lattice polygon, what I would suggest is I would like you to, when you make your conjecture here, go ahead and post a comment to the link that this video is attached to with your findings. Now, since there is some estimation involved, especially when you start looking at this shape here, you may not get the exact same answers that others do, so a discussion would make sense. All right, so here we go. Pause the video, unpause it when you're done with these two problems here. Welcome back. So we have a donut. I can't not think of it as a donut. And if I'm looking at this, to find the area of a circle, the area of a circle is pi r squared. And so really, in reality, I just have two circles, one on top of another, right? So if I take the area of the big circle and subtract the area of the small circle from it, I should get the area of the donut. Yay, I like donuts. Although, to be fair, my favorite donuts are the jelly-filled ones that don't look like this, but whatever, we'll forgive it. All right, so this distance here is 5. 5 plus 8 here, 5 plus 8 is 13. So I know that this distance here is 13 units long. So the area is equal to pi times 13 squared. 13 squared is 169. So the area is equal to 169 pi. I'm going to keep it in terms of pi for a little bit. This area here is going to be 25 pi. So I subtract them, and well, I still have pi's, right? 9 minus 5 is 4. 6 minus 2 is also 144 pi. And I'm just going to keep it in terms of pi. All right. Now for our cute little figure here with the yellow, the yellow ears. This shape here is called a lune. Now, we could find the area of the lune by doing this. We know that this shape here is equal to half of a circle. There's my equal sign. Half a circle minus this piece here. And this piece here is equal to the sector minus that. And so I could find the area of this sector here, subtract out the area of the right triangle to get this area, and then take that area and subtract it from the semicircle here. But also, I would have to know this distance here. So that makes this 11. This makes this 11 root 2. That's a lot of work. Wouldn't it be nice if there's a formula to find the area of a lune? And here's the cool thing. The lune has the same area as this right triangle. Now, obviously, if I were to move the lune, and so the edges of the lune didn't coincide with these points, it was here. Oh, sorry. If I had this triangle here instead, then I would have to use trig to figure this out. But that's not what this problem is asking us to do, so I'm not going to worry about it. So this area matches this area. And I have two of them, don't I? So the area of this triangle will be 11 times 11. That's 121 divided by 2. But I have two of them, don't I? So really, the area of both of these combined would be 121 units squared. All right. So go ahead and give this a shot, and I'm curious to know what your answers are for this. Go ahead and post them.